A very good afternoon, ladies and gentlemen. I'm Ritik Ravindran from Invest India, the National Investment Promotion and Facilitation Agency for the Government of India. I'll be your host and moderator for this seminar, Opportunities in Aerospace, Defense, and the Space Sector in Karnataka. I think the most common question we are all puzzled with is why we need aerospace and defense R&D. What is the significance in our lives? To tell you, ladies and gentlemen, every major breakthrough that has come from R&D in defense and aerospace, from jet engines to the internet to even duct tape. And we are now almost irreplaceable with all of these in our lives. We use space and its exploration to validate, prove, and disprove scientific theories we create. Insights into gravity, magnetosphere, atmosphere, fluid dynamics, and the geological evolution of other planets have all come from studying the solar system. Going forward, this research and study is only going to expand and with all possibilities and horizons. Scientists currently state that only 4% of our visible universe has been explored. This, ladies and gentlemen, is the limitless opportunity that lies before us. Currently, India only captures about 2% of the existing space industry globally, but has the potential to capture about 9% of the global market share by 2030. Governments have been very proactive in aerospace reforms, and this has fundamentally been based on four pillars, which are seen as the drivers of this paradigm shift: giving freedom of innovation to the private sector, government acting as an enabler, preparing the youth for the future, and looking at the space sector as a resource for the progress of the common man. It is here, ladies and gentlemen, that Karnataka has emerged as a leader in aerospace and defense and the space domain, establishing the necessary foothold and being the driver of the growth story along with the industry. We are honored to have the Honorable Minister Shri Murugesh Rudrapa Narani with us, the Minister for Large and Medium Enterprises, Government of Karnataka. Dr. E.V. Ramana Reddy, Additional Chief Secretary, Government of Karnataka. And Srimati Gunjan Krishna, Commissioner for Industries Development and the Director for the Department of Industries and Commerce, Government of Karnataka. May I now please request Dr. E.V. Ramana Reddy to please share his opening remarks.
Good afternoon, everyone. Shri Murugesh Nirani, sir, Honorable Minister for Large and Medium Industries, Government of Karnataka, all officers from Government of Karnataka and Department of Space, Government of India, and industry representatives and various representatives who are participating in Dubai Expo. Good afternoon to all. We are very happy to be part of Dubai Expo this year, Dubai Expo 2020. And Karnataka wanted to showcase the investment opportunities in Karnataka during this week. And this week, actually, Government of India is also in India Pavilion, celebrating this week as Space Week. So that's the reason why you all see all space Odyssey of India is depicted here. As far as Karnataka is concerned, because this is celebrated as a Space Week, we wanted to have a seminar on aerospace, defense and space sector in Karnataka. So we want to present to you what we do in aerospace and defense sector in Karnataka. As far as Karnataka and Bangalore are concerned, 1/3 of aerospace and defense component exports of country are from Karnataka. 1/4 of aerospace and defense industry in India is in Karnataka. And Karnataka contributes 67% of aircraft and helicopter manufacture for defense in the country. And in Karnataka, we have almost all major aerospace and defense companies. We have Airbus, Boeing, Lockheed Martin, Honeywell, and we have GE, Rolls-Royce, Collins Aerospace, Dynamite. So we have a lot of aerospace industry already there. And we have global capability centers of almost all major aerospace and defense companies there. And we have a lot of R&D centers in Bangalore. How it happened in Bangalore, why Bangalore and Karnataka is contributing so much for aerospace and defense. I can take you back to 1940s. Even before India's independence in 1940, the King of Mysore has set up Hindustan Aeronautics Limited, HAL, in Bangalore. That laid the foundation. Then ISRO had come. ISRO's headquarters is in Bangalore, Indian Space Research Organization. We make satellites in Bangalore. And ISRO Telemetry Tracking Center, which tracks the satellites, and even our mission to Moon, mission to Mars, were tracked from Bangalore. Then we have DRDO, lot of DRDO, Defense Research and Development Organization centers in Bangalore. We have National Aerospace Laboratories in Bangalore. And in addition to all these public sector R&D institutes in Bangalore, we have global capability centers or R&D centers of many of major aerospace and defense companies in Bangalore. In fact, in general, if you see, we have more than 400 plus, not only aerospace and defense, but entire industry sector. If you see, we have more than 400 global capability centers or R&D centers in Bangalore. Some of the companies, their largest R&D base outside their headquarters is in Bangalore. Whether it is GE, Samsung, Shell, whatever you take, majority of the companies which have naturally their largest R&D center will be in their headquarters. But their second largest R&D center outside their headquarters is in Bangalore. And in addition to the major industries which I have mentioned in the aerospace and defense sector, a lot of ancillary industries have grown in Karnataka because of these major main companies. We contribute to about 60% of the machine tools in the country. And we have 85 plus chip design companies in Bangalore. We have largest number of ESDM, electronic system design and manufacturing chip design companies in Bangalore. Then you may think why it happened in Bangalore. One is I mentioned about the public sector R&D, then private sector R&D. Third, what the state has done. We were the first in the country in India to have come out with aerospace policy in 2013. We have every 2 years Asia's largest aero show held in Bangalore. We have in the new industrial policy and in the new aerospace policy announced turnover based incentive, like up to turnover based incentive we give 2.25% of the incentive for the first 6 to 10 years. We have set up centers of excellence and aerospace and defense in Bangalore. And we have set up a large, next to Bangalore International Airport. Bangalore International Airport is one of the busiest airports, maybe second busiest airport in the country. Nearer to it, we have set up a big aerospace and defense SEZ and aerospace park there. And we are also again coming out with another aerospace and defense park in about 1200 acres there. We have brought out as a state lot of land and labor related reforms in the last 2 years. We have done a lot of work on how to improve the ease of doing business in Bangalore. And even the skilling part also, we have taken a lot of care in improving the skilling. In fact, we have the largest skilled manpower in Bangalore. That is how Bangalore ecosystem has grown. So one by one, if I keep on telling, it will be a long story. But what I would like to tell you is that Karnataka is the best place in the country for the Bangalore and Karnataka for the aerospace, defense and space sector. And as already mentioned, we have lot things which we have achieved, but we want to achieve much more. So I would request everyone to come to Karnataka, see Bangalore, see the Bangalore ecosystem and grow there. And I want you and Bangalore and Karnataka to grow together in Bangalore and Karnataka. Thank you.
Thank you so much, Dr. Reddy. May I now please request Mr. Gunjan Krishna for a presentation, Karnataka, the Aerospace Defense Hub of India.
Namaskaram. Good afternoon. Assalamu alaikum. Talking about Karnataka, as Sir has mentioned, Karnataka is a land of opportunity. It's a land of innovation and growth. In fact, the story of aerospace and defense started much earlier in Karnataka, way before India's independence in 1940, as Sir mentioned. With the setting up of Hindustan Aircraft Limited, that time it was set up by Hirachand Walchand with the help of the Raja of Mysuru, who provided him with the land. And this is how this entire ecosystem from that nucleus got developed. they started manufacturing the fighter aircrafts there for the Indian Air Force. And that's how the story began. In 1950s, we saw the iconic manufacturing public sector and private sector coming together. So we had the R&D in the form of DRDO being set up, NAL. We had these PSUs, BHEL, BEL, National Aeronautical Limited, which got set up. Also, we had these foreign companies coming in. Actually, the Bosch, which is in the form of Myco, which is the first company in the machine tool that got set up, is a German company, and they set up their base in Karnataka, in Bangalore. 1960s, we moved to the space, and Isro got set up, the space agency, the premier space agency of the country. And we had the launching of the first Aryabhat, India's first satellite, which was assembled in Bangalore. 1980s saw the fighter aircrafts being manufactured here, and we are now in total different level, and this has taken us 18 years. And as a result of which, as sir mentioned, we have all the best of the companies, you name it, both Indian and multinationals in Karnataka, which is why Karnataka is considered the aerospace and defense hub of India. 67% of all aircraft and helicopters are for defense purposes are manufactured in Karnataka. 65% of the country's aerospace related export happens from Karnataka. We are the first state to come out with a dedicated policy on aerospace and defense, and we are going to update our existing policy. We'll be coming out soon with a new aerospace and defense policy with specific focus on space and MRO sector. 70%, a very important part is that 70% of the supplier base for India's aerospace and defense industry is located in Karnataka, which acts as a basic core of the entire industry. And more than 2,000 small and micro enterprises are there and they're doing the niche subcontracting work for the major OEMs of the world. Now, talking about this, which has made Bangalore to emerge as the top 3 global airspace. I'm not talking about India, I'm talking about global. 3 aerospace cities in attracting foreign investment. So, Dubai figures as the number 2 there, and Singapore is number 1, and Bangalore, as you see it is at number 3 position. We are the only city from India which features in this list. This is done by the FDI intelligence. Now, talking about innovation, I talked about that how Karnataka is the innovation hub. We have with us 3 of the space startups here who would be talking about their stories. So we have Astrom Technologies Private Limited, who would be talking about them. Pslv we have, and we have Bellatrix Aerospace. I will be talking, they'll be talking about their story. Let me talk about some other. There is a Nopo who's not there, he's getting engaged. So this is a story of a boy who comes from Bengaluru, son of the soil. And he, as a child, wanted to go out in the outer space. And he thought that, Mars is something that we can colonize and we can start living in. But one of the questions that comes is that for a long space journey, you require sturdy and very light materials. And those materials which you can take. So we have these nanocarbons, HIPCOs, which we call. But to get them to even the professor who worked on this technology, Professor Smalley, could not get them to the scale when it comes to production. And when this guy grew up, he found out about that entire technology, that research. Professor Smalley, by the time had expired, was no more. He got in touch with his associate, set up a company which he calls NOPO, or Not Possible. Everybody told him that this idea is not possible. He named his company NOPO, Not Possible, and made it possible. And today his company is actually producing these nanotubes, carbon nanotubes at scale, and they are supplying to the best in the world, to NASA, to Lockheed Martin. So these are the stories that we are talking about that come out from Karnataka. We have with us, as I told you, Bellatrix, Pixel, and Astrom. Astrom is pioneering the future of millimeter wave wireless communication, and they'll be talking more about it. Pixel is building the world's most advanced Earth imaging satellite constellation. First was to be launched, I believe, in February on Isro's Pslv rocket. Bellatrix Aerospace is specializing in cutting edge electric and green chemical propulsion technologies for satellites. So, what we're saying is that we cover, when it comes to space, the entire spectrum. Then we have cutting edge startups which are working in the field of 3D printing. We have the people, for example, the companies which are working with the best in the world when it comes to taking information, be it coming from the camera, be it coming from the video, and giving the real time actionable inputs to the defense forces in the US, to the Airbus, to the Boeing. So we are talking the best when it comes to Karnataka. This is the company that I talked about is Hyperverge, which has the highest accuracy AI solutions implemented at scale in financial services, energy, and defense, etc. Now, talking about today, we'll be talking about 4 key opportunities for investment in aerospace and defense in Karnataka. The first, number one, I will be talking about is research and development. We invite people to set up high-end research and technology hub. As you have, I'll be talking about how Karnataka is number one when it comes to research and development. You can look at flight simulation, you can look at aircraft design, additive manufacturing we'll be talking about. Now, manufacturing is something that we've been doing, but what we can look at, more and more OEMs to come and set up, and Government of India has also allowed for 74% of the FDI to come by the automatic route. So that is something that can be explored. You can look at partnering with the leading Indian companies to establish your manufacturing, or come on your own. So there are many ways that are available. The other sector is MRO. You can set up a global MRO hub leveraging Bangalore International Airport or Mysuru. We have six airports within the state. You can also set up a digital MRO center of excellence to develop world-class engineering software, because again, Karnataka is an IT capital of Asia. Space exploration, you can set up an advanced space exploration hub to drive innovation for global needs, or partner with leading startups which are present here to develop high-tech communication and radar technology. So these are the opportunities that we will be taking up. Now, R&D. If you look at Bengaluru, we are the first in the number of patents applications which are filed versus other states in the country. And mind you, this is after that we have the 35% of the global capability centers that are located in Karnataka, and many of them do not file their patents from Bengaluru. They may be filing, say, for example, from New York or Washington or from Paris, but despite that, we are number one. We are the first in India's largest chip design hub. So any chip, they say, if there is any semiconductor, they have some element of Bengaluru in them. So 85 plus semiconductor design firms are located out of Karnataka, and 30% of India's startup are based out of Karnataka again. So this is something when it comes to the R&D ecosystem. We are home to 400 plus MNCs with the global R&D centers. Boeing, Airbus, GE Aviation, all of them have got their major capability centers located within Bengaluru only. And if you look at GE, their largest R&D center outside US is located in Karnataka. If you look at Samsung, their largest center is located in Karnataka after Korea. So such is the might, and any field you take it, Karnataka is leading when it comes to the R&D. Now, manufacturing, talking about. Now, manufacturing, if you look at all the building blocks, what is it that is required for manufacturing, for efficient manufacturing, where you get economies of scale? You would essentially require machine tool park. Karnataka is number one in machine tools. You would require, say, when we talk about IT, becomes very important. The software part, again, Karnataka is number one. When we're talking about electronics, becomes a very important aspect of manufacturing nowadays. Again, Karnataka is number one. So if you look at it, 55% of India's IoT startups are based in Bengaluru. 40% of India's software exports are from Karnataka. So all the building blocks that are required for manufacturing to be set up are there in Karnataka. Also, we have got major clusters of aerospace and defense manufacturing. We have one SEZ which is there. If you look at it, the map of Karnataka, you will find across Karnataka, spread across Karnataka, you have these aerospace and defense clusters. Many of them are around Bangalore, but apart from that, if you see at, we have an A cluster in Belgaum, which are actually having as their clients Airbus, Boeing. We have in Chitradurga, we have in Tumkur, Bengaluru. So any of these clusters, you are invited to come and look at them and invest here. Also, very important aspect of the manufacturing now, gone with the times, when if you got any product in defense areas, you could you would just stock them for 15 years and you can keep having the supplier, you have this contract and you keep working. But now the technology is changing at a very fast pace. What you have to look at is a very fast prototyping, and fast prototyping and fast getting your products in the market, you need to have additive manufacturing. Karnataka is doing a lot when it comes to 3D printing and additive manufacturing. Government of Karnataka, in partnership with Daso system, is setting up 4 3D experience innovation centers to promote skilling in additive manufacturing and mechatronics. Startups such as Delta Systems and eFarming farming are currently developing large format hybrid composite 3D printers with support from the government. And global leaders such as GE, they have got their large scale commercialization of additive manufacturing applications from Bengaluru. So what we are saying is, when it comes to the modern high tech, that is what is available in Karnataka for your fast prototyping and bringing your products faster to market. Now, MRO is another area, and this has been an area which has recently seen a spurt, mainly because of the change in the policy ecosystem that Government of India is mainly related to the GST, and then there are certain taxation issues that have been eased. So what we are offering is that we have these fastest growing airport. Bengaluru has been the fastest growing airport when it comes to both cargo and the passengers. Daily average of 630 aircraft movements that we are talking about. Again, Mysuru is a regular connectivity to major destinations that has been established, and it has a capability to accommodate. Suppose some of the major OEMs want to set up with the access to the runway. So that is something that is possible. And we have, apart from that, we have airports at Belgaum, Hubli. So number of these airports and Gulbarga, all of these airports for MRO purposes can be utilized. Similarly, now coming to the space exploration, you all know, you have heard about Isro. This is the Space Week, and we've been talking about, Mangalyaan, the Chandrayaan, the Mars Orbiter mission, the Lunar Lander Rover, and Gaganyaan, you must have heard of. In fact, there is a very interesting, when it comes to Mangalyaan, we all know, it has been on a shoestring budget. In fact, the Gravity, I do not know how many of you have seen the movie Gravity, and Gravity took 100 million US dollar to be made, whereas much lesser than that, in around 80 million, we could reach the Mars. So such is the way, that the R&D has been functioning and the space industry has been functioning. So I invite you all, to be a partner in this sector. Now, ISRO Satellite Center in Bangalore is a lead center for building satellites and developing satellite tech. We have got IceTrack Center in Bangalore, which provides tracking support for all satellites and launch missions. And astronaut training hubs are being developed at Chalikere and Chitradurga. So this is one sector which is really heating up. In fact, Prime Minister of India has recently announced Indian Space Association, and where the idea is essentially to bring it all the stakeholders together and ensure, whatever their problems, regulatory or provide them as a platform for, whatever the issues are, they get resolved and the opportunities can be shared there. So that is another thing, and a lot of things are happening in the space. So I again invite you all to participate when it comes to the opportunities in space. Now, in a nutshell, what Karnataka provides. Karnataka has got this very investor-friendly policies. for every area we have come out with a defined policy. So even if government may change, a different political party may be in power, but what remains is the stability of the policies. Ready-made available infrastructure, as sir has mentioned. We have aerospace and defense, dedicated aerospace and defense parks near to the airports, and in all the other areas we have lands available built to suit. So if you want to set up there, it is easy, plug and play infrastructure can be made available for you. Ease of doing business, very important aspect, because every manufacturer or the business person who's looking at investing would look at time as a money for them, and we make sure that through a process that there would be a single window for you. You should be, if you invest through the affidavit based system that we have created, on a basis of one approval you will be getting 15 approvals, and you will be able to ensure that your investment is grounded as soon as possible. We are also looking at highly skilled labor force available. When Tim Cook talks about, China as being a very compelling story, and how people and manufacturing has really grown there, is because of the fact that there is a coming together of high technology along with the high workmanship, and that is something which is exactly available in Karnataka. You have high workmanship, you also have high tech in the form of robotics, artificial intelligence, quantum computing, and all of them come beautifully together. And despite that, Karnataka invites skill from all over the world. Despite that, we have one of the lowest unemployment rate in the country. We are very well connected to the demand centers and gateway. If you look at geographically the way we are located, we can, within the country, if you look at it, we can become a good supplier for both the south and the central India. And if you look at east and west of the world, then both Southeast Asia, if you're looking at as a market, or if you're looking at Europe or the Africa, then again we become as a gateway. Important is that we have a world-class social and physical infrastructure that we are talking about. We have a cool climate and people with warm hearts. Bangalore is a pub city. It's a garden city. It has got, the top schools, top 8 of the international schools of India located in Bangalore itself. And what is more important is that we have a very cosmopolitan population, so very welcoming in nature. So I invite you all to come and invest in Karnataka. Karnataka stands for innovation, it stands for growth. So come with me and partner with us in the growth story of Karnataka. Thank you.
Thank you so much, Ms. Gunjan. So the significance of the synergy between the government and the industry in any sector is that it acts as a catalyst to any and all policy necessary for driving the sector in the direction of growth and advancement. The same isn't any different with aerospace and the space industry. And Karnataka has emerged as the opportune land for organizations looking at aerospace defense and space within India. So now, I'd like to call upon our esteemed and distinguished speakers for the panel discussion on the aerospace and defense and the space sector. But right now, first, I'd like to call upon Shri Umameshwaran R, the Scientific Secretary of Isro, for his presentation, sir. Hi, sir. Just go.
Right. Very good afternoon to all of you. Respected Honorable Minister for Large Scale and Medium Scale Industries, Government of Karnataka, Sri Murugesh Nirani sir. Dr. Ramana Reddy, Additional Chief Secretary, Government of Karnataka, whom I consider as part of Isro. Srimati Gunjan Krishna AS for a wonderful talk that you had given. And my young colleagues here were also able to talk, Mrs. Neha, Mr. Ravais, Mr. Rohan Ganpathi, and a host of other Karnataka government officials as well as Vicky and other colleagues and friends who are gathered here in this wonderful, wonderful Expo exhibition center. Dr. Ramana Reddy has very convincingly talked about why everybody should come to Karnataka, and Madam has further clarified on that. So my job here is to briefly take you through the evolution and the present status of ISRO, as well as what are the future plans that ISRO is going to have, and in such movements of ISRO, what are the opportunities that one can get with respect to industry as well as academia as well as startups. So I will, without talking about a brief note on the evolution of ISRO and what we are doing, the information will not be full. So I will just briefly go through that. I will not take much time. Basically, as you know, Dr. Vikram Sarabhai's vision has been transformed into the what ISRO is now, and he was constantly telling, even in 60s, that we should be second to none in the applications of advanced technologies to the real problems of man and society. So basically, ISRO has been exactly doing that even now, where whatever we do, it is aimed at touching the society, how to improve the living conditions of our society, and how to really contribute to the well-being of the society. So with that in mind, basically the idea is to harness the space technology for the overall development of the nation, and at the same time we need to continue the space science research and planetary exploration, because we have to keep our next generation always in thought, and we should kindle their scientific spirit always. So that is another activity which we should always strive to continue. We should talk about next gen. So basically, an independent access to space through social economic security, human resources development, sustainable development, etc. So if you talk about the evolution, I've tried to concisely put it in one slide. The 60s and 70s were basically the period of vision and brainstorming and dreaming, wherein what are the technologies that India needs to develop in order to become a space power, and at the same time a space technology hub in order to improve the conditions of our society. Dr. Vikram Sarabhai and a team of experts sat down and debated and brought the basically the framework of what ISRO has been doing subsequently. And the 80s were the experimental phase where these thought processes were converted into actions and missions. And you know, the first launch vehicle mission SLV-3 was launched in 1971, 79, and 1980 successfully. And none other than Dr. APJ Abdul Kalam, our former president, was the first mission director of SLV-3. So SLV-3 was a satellite launch vehicle capable of sending around 40 kilogram of spacecraft into a 400 to 500 kilometer orbit. Then we moved on to ASLV. Again, ASLV was a launch vehicle which was specifically for proving certain technologies like separation, strand separation, closed loop guidance, etc. And ASLV was capable of 150 kg, putting a 150 kg satellite onto an orbit of 400 kilometers. But subsequently, we had quantum jump in making PSLV, Polar Satellite Launch Vehicle, which has become the workhorse of ISRO till now, one of the most successful launch vehicles and one of the most reliable launch vehicles and one of the most versatile launch vehicles. PSLV became operational in 1990. We also made the next level of launch vehicle, GSLV, Geostationary Satellite Launch Vehicle, which is capable of sending a 2-ton kind of payload to geostationary orbit, specifically aimed for communication satellites. PSLV was basically designed for Earth observation satellites in 1,000-kilometer orbit, but PSLV is also a very versatile launch vehicle. It can go to geo also. And 2020 became the expansion phase, wherein we wanted to further dwell into the deeper realms of new technologies. We had very good satellites, high of the cutting edge technology like high throughput satellites, multispectral satellites for Earth observation, and and the design phase for the next powerful launch vehicle GSLV Mark III was also on the anvil, which was capable of taking a 4-ton kind of payload into geo orbit. Basically, now beyond 2020 is the self-reliant ecosystem development, wherein the government last year has announced the opening of the space sector for the enabling the private sector to carry out their specific space activities within India. And the idea is that till from 60s onwards, we had a very strong bond with the private sector, but they were basically kind of vendor relationship that we had. We had developed quite a number of very good medium scale and large scale industries. But the idea now is to see that they start investing and carry out their independent space activities. So we need to handhold them and promote them. So that is basically the kind of unlocking India's potential, and then corresponding establishments have been made. I will dwell upon that. At the same time, ISRO will continue to do its own job of making missions of national importance, of national and social relevance, at the same time going ahead with the scientific and space exploratory missions. So if you talk about the organization also, there is a modification now compared to the earlier cases. We have established a new regulatory mechanism which is called InSpace. Basically, as I said earlier, we didn't have a mechanism for hand-holding, at the same time regulating and authorizing the private enterprises to carry out their activities. Now a mechanism is there in space with Dr. Pavan Goenka has been designated as the chairman of InSpace, and basically InSpace mandate is to handhold, promote, at the same time regulate and authorize the activities of the private sector as far as space activities are concerned in India. And as you know, otherwise ISRO has 7 major centers, 7 units and 5 autonomous bodies under Department of Space. Now the new regulatory mechanism is also added. You can also see that it's a pan-India organization covering almost all parts of the Indian country rather. What we have achieved till now, if you really ask me, we have 78 successful launch vehicle missions and 111 satellite missions and more than 250 application-oriented missions. We have launched more than 330 satellites for other countries, specifically other countries. We had 4 technological demonstration missions, very interesting missions. At some other point of time, I can dwell upon that. We have assets, we have 50 satellites with 19 communication satellites, 2 meteorological satellites, 18 Earth observation satellites, 8 navigation satellites. I'm very proud to say, that our own navigation constellation is in action now. It is called NAVIC, and we have 3 space science missions also. So if you talk about the overall structure, if you call it, is based on 5 basic pillars. We need ultimately the space application is the ultimate pillar, I would say, because the application directly goes to the society. So space application is the strongest pillar, and in order to achieve this space application, what do you need? You need the data from the space, and in order to get the data from space, you need the resources in the space, and basically the space infrastructure, which is nothing but the satellites that we have on board. That is the second pillar. And in order to see that the space infrastructure is there in the orbit, we need space transportation system, which is nothing but the launch vehicles. And definitely capacity building is a part of that, because unless you develop the human resources, unless you develop the kind of infrastructure that is required, the kind of test centers that is required, it is extremely difficult to further grow. So capacity building is an extremely important aspect, and outreach is another very critical aspect that any organization needs to develop. So we have very strong outreach activities, especially with respect to outreaching the startups, the academia, and other institutions. And very recently we have added human in space program also as another pillar, because the dimensions of human space activity is totally different, considering the reliability issues that are very much required, considering that a human is going up, and it's our responsibility to see that he comes back safely back. So, as I said earlier, the whole gamut and the landscape of space activity has changed. Earlier, from the government funded and the government conducted space activities, now we are moving towards private funded and private conducted activities. So basically, space based services and applications have, I would say, have remarkable spiraling growth nowadays, and the demands and the requirements are also exceptionally high nowadays. So the total dynamics with respect to space activities that is happening all around the world is spiraling like anything. And ISRO as a government organization alone will be totally insufficient to handle this new demand. So it is high time that we take on board the private players as well as academia into confidence, and at the same time encourage them to do these activities which will ultimately result in making the Indian economy much better and much stronger and much vibrant. So basically, and as you know, the opportunities are unlimited as far as this business is concerned. So basically, I am sure nowadays, based on the interactions that I had, at least personally for the last 1.5 years, the private sector definitely is ready for making the launch vehicle, making the satellites, and providing the space-based services. So basically, as I said earlier, the paradigm change from government funded to private funded has necessitated the space sector reforms. And what are the reforms? So basically, we need to promote, handhold, at the same time authorize and regulate the activities of the private industry, and we have also introduced a public sector under the government of India, which is called New Space India Limited, when they are mandated now to carry out the commercial activities which earlier ISRO used to carry out. The New Space India Limited will be doing the commercial related activities. Basically, the dimension has changed from the supply driven mode to a demand driven mode. It is now people who need has to demand, and then that has to be delivered. So, and NCIL, the mandate of NCIL has been further transformed so that NCIL is now made enabled to own assets and carry out application oriented activities. So, as I said earlier, enabling the private sector to carry out end-to-end space activities in space has been established, and ISRO, as I said earlier, will focus on the development of new technologies. And a very, very important factor that we are telling is that some of the facilities which ISRO has and which is not available otherwise in the country are being extended to the private companies as well as the startups, so that they need not invest that much money into that, establishing such infrastructure which is huge, which amounts to huge cost, and that will really hamper their further activities and return of investment concerns. So this is a policy that we have introduced now. Whatever that is not available elsewhere in the country, we are ready to offer to them, of course, at an affordable cost and depending on the schedule constraints that both of them have. And this has been really welcomed, I must say, by the private entities. And as I said earlier, the CPSE NCIL will carry out its own private commercial related activities. And ISRO is also continuing to do its announcement of opportunities, wherein one more important aspect is the technology transfer has been, the method has been eased now, so that at a very reasonable cost, the offshoots of the technology that ISRO has developed will be made available to the industries so that they can use it for their space activities, and also at the same time they can transform into certain other components which are commercially viable in the market. So the possible activities a private sector can definitely do as far as space activity is concerned is building and launching a satellite, owning and operating a satellite, providing the space search services, and building launch vehicles and providing launch services. As I said in the morning in one of the debates that we had, if you talk about the overall percentage wherein the cash flow really happens or the profit really happens, the more than 45% lies in the upstream activities, that is basically the ground station related activities, and around another 47% lies in the space-based services that one can offer. Basically 2% only with launch vehicle activities and 3% with satellite activities. So this is the kind of scenario that exists, and any private industry or any startup that is coming can judiciously invest in such a way that they earn their own targeted profits and at the same time contribute to the Indian economy. So basically, as I said, the in-space I've already talked about. And basically the construction of in-space is in such a way that it has a chairman and it has got 4 directorates: technical directorate, safety and security directorate, legal directorate, and promotion and monitoring directorate. And any private firm or any startup can directly approach the in-space. The kind of interface is so simple and direct, and it will be followed by interactions, discussions, and then maybe we'll enter into MOUs, we will enter into non-disclosure agreements, followed by going ahead with the activities. And to give strength to that, to give teeth to that, almost 10 space-related policies are being on the anvil. As you know, the SATCOM policy has been now transformed, and the new space, as it is called Spacecom policy, it is almost on the threshold of getting approved. We are also modifying the Earth observation policy. We are bringing a new navigation policy. We are bringing a new launch vehicle policy. We are bringing a space exploration policy. More than 10 policies are on the anvil, and 2 more important policies that is again in the anvil is FDI policy and technology transfer policies. So with all these policies, definitely the process is going to become much more simpler, much more transparent, and much more direct. So if the opportunities lies in all these areas. If we talk about space transportation, you know, PSLV, GSLV, and Mark-III are the launch vehicles. Already a consortium of industries very soon will take over the entire end-to-end production of PSLV. So after maybe in a couple of years, Isro may stop making PSLV at all, and the consortium will start making the PSLV, so that as envisaged, from the 5 to 6 launch vehicles that we are launching yearly basis, it should be at least double to at least 12 per year. So this is definitely one of the bottlenecks that we have. We have very limited industries which are making launch vehicle components. Unless more and more industries come forward, invest, and do their business in making the launch vehicle components, we cannot increase the number. ISRO will not be able to produce in large numbers. So then GSLV and GSLV Mark-III, only 4 missions, all are success, but number is less. So more and more GSLV Mark-IIIs, if you successfully launch, it will become one of the most reliable launch vehicles in the world. So this is another opportunity in front of all the industries. We are going ahead with the new technologies, which are also, we are giving announcement of opportunities for industry, startups, and academia to participate, like reusable launch vehicle. Ultimately, the reusable launch vehicle is what we call an SSTO, single stage to orbit mission, wherein just like an aeroplane, it will start, lift off from the runway, go to the space, be in the orbit, come back and re-enter and land like an airplane. That is ultimate reusable launch vehicle. So initially we had already demonstrated a subscale version of reusable launch vehicle, and that is successfully, that is with a small rocket, we have sent it to orbit, it has come back and landed in sea. Now the next step is to make a full scale of that, send it to orbit and make it land. So step by step we are going ahead, and we expect that at least this will be, we will be able to demonstrate by 2025. That is our expectation. Before that, we are taking a full scale RLV, taking into an aircraft, and we are going to land, that RLV will land in land instead of sea in our this Chelagare, as madam mentioned. So this we are expecting in another 3-4 months. It will be a very exciting thing to watch. So like then pad abort test was a precursor to our manned mission, wherein safety is paramount, and there are 100 types of failure mechanisms which can create a failure to any mission, and we are simulating those failures. Suppose something happens in the pad itself, how to make the astronauts escape and make them safe. So that is called pad abort. In the pad itself, they will be taken away fast to 2 kilometers away, and they will safely land in sea. So this test was successfully conducted. So like that, Scramjet is another very interesting technology. Basically what Scramjet does is, it takes the oxygen from the atmosphere during its atmospheric regime. You know, any mission, any engine needs an oxidizer and a fuel. Fuel is already there, so we need to carry the fuel as well as the oxidizer. So if you remove the oxidizer from the storage part and use the atmospheric oxygen itself, that much weight can be reduced and that much mass can be added to your payload. That is called Scramjet. And successfully we demonstrated a miniaturized Scramjet engine which fired for 18 seconds on its own, which is a world record. Even NASA has demonstrated only 9 seconds. We could do it, and others scaling this up. So these are all the opportunities that you people have. And some more, I can go on and on. Uprated cryogenic stage and cryogenic engine is under the development. And the second stage for which we used in GSLV Mark III, we wanted to make it more powerful so that we can have more bigger rockets. Like that is called the 6-ton. Now, as I told, GSLV Mark III is our biggest launch vehicle with 4-ton capability. We wanted to make it 6-ton to 16-ton and even 50-ton later. So it is called a modular kind of launch vehicle with big boosters. So these are all some of the LOX methane engine is another very critical technology with which we can still improve our payload. So these are all some of the and the small satellite launch vehicle is another very interesting thing. It's a small launch vehicle designed, and most of our startups are also in the same process. The small satellite launch vehicle has got the capability to send satellites of the order of 300 to 400 kg in 300 to 400 kilometer orbit. This has had a huge demand in the international market. So many startups are also in this process. Our first experimental launch is scheduled by next March. So this is a very attractive proposition because it's very cheap. The whole launch vehicle costs only 30 crore. So your satellite cost will tremendously come down and we will be internationally competitive. So, and one more interesting thing is we are offering the 4th stage of PSLV, Polar Satellite Launch Vehicle. The 4th stage of PSLV is wherein you can see in the figure, the 4th stage on top of it, the satellite is mounted. And once the satellite is ejected into orbit, basically the 4th stage is on debris. It will remain in the orbit for maybe 1 year and then fall back to Earth, burn itself out, and it will go. So what we thought is, if we give some solar panel and make it live for another 6 months to 1 year, that can be an excellent platform for low Earth orbit kind of experiments. So we have given an announcement of opportunity even in the UN USA. We announced this, wherein we can do a host of experiments like serology experiments, biological experiments, deorbit and re-entry experiments. I can go on and on. And the startups who are we are trying out with new theories. I think I am inviting them. Please provide some of your technologies for demonstration into PS4 platform, which will be an ideal platform for you to carry out your experiments. And this can be done free of cost. There is no cost involved here. You only have to take care of yourself. That's all. So same thing I am talking with respect to satellites also. We started humbly with, if you talk about, as Madam told, Aryabhatta, which was our first remote sensing satellite we made in Bangalore. And another was Apple, which was our first communication satellite, which we sent through Arianespace. And from there, we have reached up to GSAT series of communication satellites, Cartosat series of remote sensing satellites. In fact, Cartosat 3, which we launched recently, has got the best resolution in the world. It is 0.27 meters, that is 27 centimeters, which is one of the best in the world. And the same resolution was used in our Chandrayaan 2 also. And we have got beautiful images. I'm not, due to lack of time, not going further into this. Enormous opportunities exist for you people to get into this. And with respect to space application is concerned, I don't want to dwell further. It is, I can go on and on. The kind of the applications that is demanded, the application that is available, it is mind-boggling. Your opportunities are infinite, I will say, and this is where money lies. And as far as navigation satellites, I told you earlier, it's so location-based services, not only location-based services, the navigation constellation offers so much of diversified applications. Lots and lots of opportunities are there. And actually, the passion of Honorable Prime Minister must be really appreciated. He, in 2017 itself, he took direct initiative in seeing that 60 of his ministries were asked to present what they will do with their satellite data made available to them, and what is a kind of applications that they will develop for the benefit of the society. And we had interactions with 60 ministries. Around 151 projects were developed, and almost all of them are on the completion stage. I think most of them are completed. So this is a kind of interest the government is also taking, and we are further trying to take this forward. And these are some of the, I don't want to talk much about it. Chandrayaan 1, Chandrayaan 2, Mars Orbiter mission and all, much talked about. In fact, Mars Orbiter's mission, we intended only for 6 months. It is already 5.5 years, and even now we are getting wonderful data from Mars Orbiter mission. And if you talk about the cost, it is less than 6 rupees per kilometer. If you really talk about the kind of distance it traveled, it is cheaper than an auto rate. So I am not going into film, even without that. And AstroSat is a very, very prestigious product. It is our only observatory in the space, and it has got enormous appreciation all over the world. A lot of papers have been generated by the data which is provided all over the world. Let me tell you, the data from Chandrayaan 2, Mars Orbiter mission, AstroSat is given all around the world for free. All the scientists and other researchers who are doing the business in this particular area are free to take the data, and they are doing it also. And the new missions, Chandrayaan 3 definitely, because Chandrayaan 2 was a near miss as far as the landing is concerned. So this mission is exclusively for landing and making the rover land. So this we are planning by next year end. Aditya L1 is a mission that we are going near to the sun. That is the next mission, wherein we will go to something called the Lagrange point 1. This is a very, very exciting mission. Here also opportunities have been announced. Lot of scope are there for youngsters to prove their theory and put the payload into the satellite. One slide or two slides on human space flight Gaganyaan mission. As I said earlier, this mission was announced by Honorable Prime Minister on 2018 in Independence Day, and he had given a very tough task of succeeding by 2022 before the Independence Day to commemorate the 75th anniversary of Indian independence. Unfortunately, we were in the right track, but unfortunately, COVID struck, and we got stuck. It's a fact. So, because unlike the other industries where work from home is possible, in rocket business, you cannot work from home. And also, industries, I told you, more than 90 industries, 90% of work is done by industries. And because of COVID, industries also got stuck up. So we were totally helpless. Now we have come back, and at least we are trying to aim that the first unmanned mission will go before the next Independence Day. That is our plan. And maybe within next 1 year, we will make that manned mission. That is our target, and that is our hope. And this mission is a very interesting mission. It is a pan-India movement. It is not ISRO's mission. It is not only ISRO. The defense is involved, the academia is involved, many startups are involved, and many major industries are involved. It is a pan-India mission, and the developing the launch complex facilities exclusively, especially the astronaut training facilities, the astronaut quarantine facilities, all new things are required, new ground stations are required. Then we had in very successful international contracts for various activities, including the spacesuit. You can see it in our space pavilion very soon. In a couple of days, I think the spacesuit will be there in the pavilion. You can see that. And our selected astronauts have been undergone their training in Russia. Russian leg of training is completed for the last 1.5 years. They were there, and they have come back for the Indian leg of training. This is going in a very fast track mode. It's a pan-India mission, I want to reiterate once again. And capacity building, as I said earlier, we had 261 memorandum of understanding with 60 nations and 5 multilateral bodies. And one of the classic examples I would say is the NASA ISRO synthetic aperture radar mission, wherein NASA is also JPL is giving a payload. We are also giving a payload, and it is launched by India. The satellite is also made by India, and it's a beautiful mission slated to be in the first quarter of 2023. And very interesting thing is we are making a small satellite development for Bhutan. There are 4 Bhutan youngsters who are trained there. They have come to India. We have trained them, and they are also joining us in making the satellite. And this will be launched probably by end of this year or first month of next January next year. So these are all some of the ideas of Honorable Prime Minister himself. The GSAT-9, which was launched in 2017, is a classic example wherein that entire satellite was dedicated for our neighbors. The transponders were given free of cost to our neighbors. It's the first time in the world. Nobody else has done it. So these are all some of the novel things that being done. So to put it in a nutshell, see there are tremendous prospects for partnership, be it in the launch vehicle realization, be it in the spacecraft realization, be it in the spacecraft operations, or be it in the applications. It can be in the participatory mode, wherein it can be built to specification or built to print. Both are possible, and it can be done at different levels also. You can come for design and development level, you can come for component level, or both. You can come for subsystem level, you can do this up to system level, you can do the entire activity integration level, and end to end also you can do, and just give us for launch, or you yourself can launch. And all facets of activities like design, development, fabrication, testing, operation, everything, there are opportunities. So please talk to us. It will be done. So with this, thank you very much.
Thank you so much, Mr. Uma Maheshwaran. I'd like to now call Ms. Neha from Astrom for her presentation.
Good afternoon, everyone. My name is Neha Satak, and I'm the co-founder and CEO of Astrom. We are a deep tech startup building cutting-edge technology for the next generation of internet infrastructure. As we all know, the data demand in the world is increasing exponentially, and in the future, we will require connectivity to be present everywhere. The data demand is not just in urban areas, but also rural areas, and soon we would require good quality connectivity in the sky, in space, everywhere. So to have, to fulfill this kind of a requirement, what is required is a ubiquitous backhaul network which can be available for anybody to create a network on demand. And we at Astrom are basically solving that problem through our technology. The tools that are available to us today are primarily driven by fiber. Fiber has limited reach because it's, first of all, really expensive to lay fiber in rural and remote areas. And second of all, fiber also takes a long time to get deployed. So you need sort of technologies which can complement fiber. And most often in the last 20 years, what we have been using is satellite connectivity, but at a very, very small scale. And the satellite connectivity that we have been using, the whole world has been using mostly geostationary connectivity, which is, of course, not at par with the kind of data requirement that we have today in terms of latency as well as in cost. LEO satellite constellations are coming up, but at the same time, the LEO constellations that are coming up are still not very cost effective, primarily also, mainly for the developing countries. It's probably, reaching that stage of being, cost effective for developed nations, but not really for developing countries still. So in the backdrop of that, when we started Astrom, we had just one vision. We wanted to use technology to bring high bandwidth, low cost connectivity across land, air, and ocean. So that's kind of the underlying vision of Astrom. And today we are creating very cutting edge technology. In fact, our first product is the world's first multi-beam E-band radio. E-band frequencies are 70 gigahertz to 90 gigahertz, and we are the only company in the world who has a multi-beam product in this frequency spectrum. Going to higher frequency, what you achieve is a lot more capacity. You can go to multi-Gbps speeds, in every link that our device makes. And in the future versions of the product, you can even go till 10 Gbps kind of speeds for every link that our radio makes. And how that helps is that if you look at the world infrastructure, in developed countries, about 80% of the existing towers are connected with fiber, and 20% are mainly connected with low data connectivity. In developing countries, the equation is much different because only 50%, less than 50% of the towers are actually connected with fiber, and rest of them all rely on wireless backhaul. But the wireless backhaul solutions that are available in the market are either high in cost, or they do not provide the kind of data throughput that one needs in today's time. And so our solution basically provides fiber-like bandwidth wirelessly so that we can piggyback on the existing fiber that exists in small towns and cities, and extend the connectivity to suburban areas and rural areas. So it basically solves the problem of last mile backhaul. And this technology is something that we are today basically, trialing with our customers, not just for the rural sector, but also for defense. So we are also a company who is using our products to solve a lot of the communication needs of the defense sector, especially the army. India has got a really long border, and we need connectivity. Connectivity is a must when it comes to today's, warfare and requirements. So that's another problem that we solve with this technology. And the future of this product is also to solve some of the 5G problems which world will experience. Right now, only the early 5G deployment has happened in most countries. Of course, developing countries, it's still being planned. Nothing is deployed yet. But soon we will have a problem that we will have a lot many more cell sites. We will have 5 times more cell sites than what we see today, and we will need high bandwidth capacity at each of those cell sites. So there is a need for wireless technologies to sort of take the fiber capacity and deliver that to each of these new upcoming cell sites. So that's also another thing that our product delivers or will deliver for the 5G networks. Now, you may ask, why is this technology important? Because at the beginning of my presentation, I also said that it's really important to have solutions which are cost effective and also quick to implement. Because if you have a solution which is cost effective and it takes 10 years to deploy, sorry, that's not going to work, because the data demand is today and now. So the kind of solutions that we are creating, first of all, the basic pillar of those solutions is that they have to be low cost. And the first product that we have launched, which is called Giga Mesh, actually delivers about 50% reduction in capex cost and 30% reduction in opex cost with the best of the wireless radios. As compared to fiber, it delivers 1/6 reduction in cost. It is also very quick to deploy because the product is completely software driven. The deployment and the maintenance of the product is all taken care of automatically, which is not true for all the other E-band products in the market. And it's also very easy to maintain. Now, with this picture, I also want you to know that the core technology that we have developed is basically the next step for us. The next milestone for us is actually to translate that technology into space. So let me tell you how. If you look at most of the LEO constellations that are coming up and also the geostationary satellites, they're all in Ku and Ka bands. And KU and KA bands frequencies are getting more and more congested. They've been utilized, but they've been utilized to an extent that no longer there is high capacity available, high bandwidth available. So the world inherently has to move to higher frequency, even in the satellite communication domain. And the frequencies that are going to emerge are Q and V and W bands. And today, we as a company already have the technology in our first product, which can actually go, with which we can actually deliver W band payloads. W band payloads for LEO constellations, which can help satellite operators to crash the cost of satellite infrastructure by a factor of 10. And we do that because if you look at every LEO constellation from SpaceX to OneWeb's constellation, the max data throughput that the satellites can achieve is around 20 Gbps in the KU band and KA band. We make that capacity with our new payload technology to go to up till 100 Gbps. And that means that whatever money you're spending to build one satellite, you're getting basically 5 times more capacity to sell to your customers. And so that coupled with many other innovations that we are bringing to the market in the space domain will help us achieve cost effectiveness in satellite connectivity for the developing countries as well, not just the developed countries, but also developing countries. Also the first step that we are taking is, solve the ground terminal problem, because as we all know, I'm sure, a lot of articles have been written that the ground terminal, which is going to be used with the LEO constellations, is a key technology to be cracked, for making satellite internet even, achievable to be used at a large scale, in the world. And so we are applying our technology to both build the payload side of things and also the user terminal. So we are soon going to be, launching our KU band flat panel antenna first, and then moving on to space to basically make W band payloads. So that's where we are. This is our team. So I am the co-founder and CEO, my partner Prasad, and our president Venki, who's here today. Venki has 30 years of experience, in business. Prasad and I both have PhDs, and we are basically entrepreneurs at heart, but also researchers at heart. So we are basically at the right junction to create new technologies and also to commercialize them. And then we, of course, have technical experts. One of the best, few of the best engineers that are there in India work with us, and we are very proud of our team. So what I want to, leave as a thought, of course, we have won a number of awards. The most prestigious award that we have won is from International Telecommunication Union as basically the best connectivity SME, company in 2020. And we have, of course, been, okay, I think there is a problem. No worries. I will, just close my remarks by saying that, what the world needs is a ubiquitous backhaul infrastructure so that anybody can build a network at any place. So the data demand today is not restricted to one place or another. It has to be everywhere. The network has to be able to deliver connectivity at any place. And for that, we need a combination of technology, including fiber, satellite connectivity, and wireless radios to all come together in, building the different pieces of the jigsaw puzzle. And we as a world need to evolve to that, connectivity infrastructure. By keeping them separate, it doesn't help us because, having satellite communication separate, then, terrestrial network, it only creates underutilization of each of those resources. So that's the vision that we want to work towards. And we are looking for partners, as well as, we are going to be entering the US market soon. So we are looking for, telecom companies who may want to license our technology, and, deliver solutions to telecom operators. So with that, I would like to thank you all. for giving me your time. Have a good day.
Thank you, Neha. May I now call upon Awais from Pixel for his presentation.
Hey everyone, this is Awais. I am the co-founder and CEO at Pixel. We're one of the Indian new space startups building our own constellation of satellites. So the story of Pixel starts when my co-founder Kshitij and myself, we were still in the final year of undergraduate studies in India, still entering into a fourth year, and we wanted to work in space technology because that was our love since many, many years. And we wanted to be able to set something up so that as soon as we finished our college, we could jump into a space company, and Pixel is the result of that. What we started off as students, since we didn't have a lot of money, of course, was there existed a lot of satellite imagery that was coming down from space that was not utilized anywhere near its potential. You could use it for monitoring illegal mining, you could use it for identifying pest infestations or crop diseases, you could use that for identifying emissions that are happening that are causing pollution, air and water pollution everywhere. And that's something that we had firsthand seen while studying there. Some of the world's most polluted cities were very close by. The state that we were studying in was rampant with illegal mining. Every year we saw headlines about how many crops are lost due to pest infestations. And the result of that was what we wanted to do was build a health monitor for our planet. Essentially have one place where you could see how the health of our planet is changing on an everyday basis, and then use that information to actually monitor these problems, to be able to predict how this will take place, and use that to take corrective action down here on Earth. But the problem we realized was that existing satellite data, even though it was really good for a lot of use cases such as making maps, such as infrastructure mapping, still lagged what was the killer touch. It couldn't see the emissions that were happening, say for example from oil and gas pipelines. It couldn't identify and map out which pest infestations and crop diseases were actually causing havoc, whether a particular area of land was under irrigated, over irrigated, or whether the problems were due to some sort of a crop disease. And there was a big gap, there was a big opportunity in building and launching a much better class of satellites that were there, simply because existing satellites, all existing satellite constellations that are currently operating today, are blind to a whole host of global problems that we cannot even see. And how did we want to solve that? We could solve that by building and launching our own constellation of satellites that solved this problem. And these satellites were called hyperspectral satellites. The hyperspectral part is what enables us to beam down data that's 50 times richer in information. So instead of just seeing whether a particular part of the land is crops or not, we can actually identify which species of crops we are looking at. We can identify whether there's a pest infestation or crop disease and map exactly what disease or problem that is. We could identify oil and gas leakages happening, be it from above ground natural gas pipelines or from underground oil pipelines as well, which cause a lot of harm to the environment. So the constellation that we would build would, one, provide global coverage. Once the satellites are up there, we'll be able to see what's happening any part of the globe. It'll be able to provide daily coverage, see how things are changing on an everyday basis, and we wanted to make it widely accessible as well by keeping it the lowest price on the market. The more companies and organizations and the governments that use this data, the more use cases that will come out of it. And to enable that, we needed to make sure that this was very cost effective. And finally, unprecedented resolution globally by building and launching the world's first hyperspectral constellation. And this is not just on paper. We have already built the first of our satellites. It's been tested multiple times over. We used the facilities at Isro in Bangalore itself to test this satellite at the final stages, and it's also booked to launch on an Isro Pslv rocket that's hopefully going up in the next few months. So we're looking forward to the launch of our own first satellite that's been built in India and will be launched from India as well, and a second satellite soon to come thereafter in Q1 of 2022. We will follow this up with 30 more satellites in 2022 and 2023 that will complete our constellation, and we're already begun the manufacturing of the first stages of our constellation today. There's a large opportunity today, especially in India and Karnataka, backed by strong trends. With the government opening up the policy last year, we have been able to now get a clear line of sight into how exactly our own satellites can be manufactured, licensed, and launched out of India. And it's not just us. You can see there's a lot of rocket companies that are coming up. There's a lot of supply chain companies that are providing things. There's a vibrant ecosystem that Isro has already set up in India that we are making use of, and there's a more vibrant ecosystem that's also coming up. And combine this with the Isro infrastructure and support that's already there. As I mentioned, the example of our own satellite being tested at the Isro facility, being launched by an Isro rocket, and more things that we hopefully will be able to do together. There's a large opportunity both in Karnataka and India, where startups like ourselves and the other startups that are speaking here are also able to leverage. Going ahead, we look forward to making sure that the technology that we're building that's unique globally can also be used for public-private partnerships with the governments themselves. We have a whole host of customers globally that's already signed up, but making sure that this technology, as Vikram Sarabhai himself stated when Isro was being set up, we need to be second to none in the applications of space technology down here on Earth, and Earth observation data like hyperspectral images can do that. So if we can help out the government everywhere here in our own state as well as globally to make sure that better actions are taken by back data, we are able to do that. So that said, we're making satellite imagery actionable by seeing the unseen, that the problems that are not seen today, and the satellites are launching soon. Thank you again for this opportunity, and we can interact more later.
Thank you so much, Awais. I'd like to now call upon Mr. Rohan Ganpathi from Bellatrix Aerospace.
Once again, good afternoon, ladies and gentlemen. Nice to be with you in the afternoon session as well. Before I talk about myself, my pranams to Honorable Minister, Mr. Dr. Ramana Reddy, our mentors from Isro, Uma Maheshwaran sir and Sudhir sir. If I might take the privilege, let me call myself our company Isro's baby. This is before all the policies were set rolling. I was a college student, 19 years of age, just fresh out of an accident, trying to build a rocket motor out of sugar propellant and agriculture grade potassium nitrate, which just exploded. And then in Mysore, my co-founder and I, it's just a city 3 hours outside of Bangalore, we're discussing how to build an engine which runs on water as a fuel. Yeah, I'm 28 now, so it looks like a long way back. But it was 2011 when we had this thought. And we went to, of course, when Madam was talking about the opportunities available in Bangalore, so Isro was just a stone's throw away, right, the distance. And also Bangalore has Indian Institute of Science, India's #1 technical institute for high-level R&D. So they said it is possible, you can do, but how do you do? We went to one of ISRO's centers. Sadly, director of that center is no more with us, Mr. Ramakrishnan, who encouraged us to proceed with this technology. And that idea took us to meet Neil Armstrong, Buzz Aldrin in NASA, your childhood heroes, and then, of course, Dr. APJ Abdul Kalam, who also encouraged to take it up. Because, see, space is no longer science fiction. We are talking space as the big industry, and we believe, coming from the IT capital of India, Bangalore, it can also be the space capital of the world by creating more employment opportunities. So with this, Bellatrix was started. What do? We build engines for space, basically. More on that little later. There's a famous saying which each and every one of you know. There is gold available underneath the ocean bed, but why don't we go and mine it? You know, the cost of gold, the cost of mining is more than the value of gold. So it doesn't make sense going and getting the gold. Similarly, you know, moon is so rich in natural resources. We are talking about climate change, how space can address the problem of climate change. But is it economically feasible in the theory of planetary trade, as I may call, to go and mine on the moon and bring something back? it doesn't, right? Yeah, it's not feasible so far, but things are changing. So that's when I heard the Prime Minister talk for the first time that ISRO reached Mars, as even Sir was telling, under 6 to 7 rupees per kilometer charge. That's when I said, Sir, we have done something in which we can go into 7 paise. It's just like 100 paisa is 1 rupee. So we did a math, 7 paise per kilometer. Can we do an technology? So of course, water is abundantly available on Moon, in the form of ice, and in Mars. So with in situ resource utilization, when you have such engines, you can bring back a lot more material from Moon. So this led us to develop the world's first electric propulsion system, which runs on water as a propellant. Right? That's how our journey started, and it was not smooth. So when you build something for space, you have to ensure that it works. You can't send a service person out there to service it, right, if something goes wrong. So for a startup, that's one advantage you have with Karnataka and IISc and ISRO hand-holding together. They taught us what is the nitty-gritty and the quality which goes in to develop something like this. And I'm happy to say we are living at an era, 2015 to 2020, this period where a lot of changes happened and a lot of things became accessible to companies like us. So now we are in the space propulsion systems area, meaning we provide engines for all classes of satellites. The purpose of a rocket is to put a satellite in orbit, but not to its final destined orbit. It's only to give sufficient velocity to orbit around the Earth. But from there to go to your dedicated orbit, you need engines, and that's what we do. And satellites, just like cars, come in all shapes and sizes. And we are the only company in the world which specializes in all kinds of propulsion, meaning from nano satellites, which weigh are less than 10 kilograms, all the way up to 5-ton class of satellites. So that's what Bellatrix does. Initially, we'll help in moving or putting satellites to orbit, and next comes constellation management, and then of course Moon and Mars. We also looked at how other technologies are coming in space. So green is not just for Earth. Even in space, everything is green. So with the number of constellations coming up in space, even orbital slot is becoming just like a real estate. So it's so expensive. So there is need for propulsion. Once the end of your life, the satellite still stays there as on today. But you need to have the capability to deorbit it. So that is something which we intend to do. These are our product line. So you can see different thruster names. Microwave plasma thruster. It's a water powered thruster. We use water to create a plasma, which then expels out at higher velocities, which gives you thrust. This is for communication class of satellites. We have Hall effect thrusters or nano thrusters. These are for small satellites which weigh up to 1 ton. And then we have green monopropellant thrusters. In the morning session, the director of Human Spaceflight Center was talking about green technologies for re-entry. So this is something which we are actually doing using green propellants. Europe has already taken this plunge because storing and making these propellants is also an expensive affair, and that's where we come. So we want to be called as the Uber of space, right? So that's where we fall into, in simple terminologies. What you see here is the products in action. The first image is an electric propulsion system called Hall thruster that ionizes a gas which turns into a plasma and it accelerates. The third image is what we delivered to ISRO. This is a water powered thruster for communication class satellites, and we delivered this in 2016, and this is the first 3D printed rocket engine, as I could call you, which was delivered. And one advantage of being in Bangalore was aluminum 6061 alloy is still even today difficult to be additively manufactured because of its properties. But there are industries in and around city where we worked out production methods to overcome this. In fact, it has been tested in one of ISRO centers as well. And then you see world's smallest thruster ever developed. We call it as the nano thruster. We collaborated with SCL Chandigarh, again one of ISRO's main unit, which has manufactures semiconductors, to use fusion of electronic chip manufacturing technology to propulsion. So we could innovate, and that's the size of the thruster which you see. It's so small, undergoing qualification now. Bottom months you see water vapor plasma coming out. I might be the temperature. So a lot of material science goes into it to ensure that this product is also water vapor and it's green. And with these products, we are qualifying them this year in space, and we wish to go global with these tech. And of course, with the number of constellations coming up globally, there's a need for propulsion to ensure that there is good behavior in orbit. You don't go and collide with your neighbor. And also at the end of life, you deorbit, right? So that's what we do. And we have also set up Asia's largest privately funded facility where we can test and develop and deliver all classes of propulsion systems. Of course, manufacturing, we work with vendors based out of Bangalore, where capability is there. So I extend an invitation to all of you to visit our lab. It's inside the Indian Institute of Science. And I wanted to mention one thing. In this slide, you see, of course, we've got a couple of recognitions. The center one, Elevate 100, it's a Government of Karnataka initiative. When we were struggling to build, when you have something idea to POC concept, how do you take it from idea to proof of concept when before an investor believes in you? So this is where it's a flagship initiative of the Government of Karnataka, where you are given good grants. With that grant money, you can increase your investor confidence. So I'm happy to say we are the first winners of that particular award. That led us to the other recognitions which you see in this slide. And that's the advantage of being in Karnataka. And of course, when in space, you can't be alone. You have to work with your partners as well. And we are other than ISRO and DRDO being the national agencies, the upcoming startups we are working with very closely because everybody is complementary in other way, and together to be a global spacefaring nation or to give global world-class products for interplanetary requirements. So you have to partner with other companies as well, and which is something is already happening in India. And it's a very exciting time to be. And what's our advantage? To put in simple terms, will be your Uber of space to move your satellites from one orbit to other and deorbit it and take care of your constellations while you're in space. I'll keep it short. Thank you very much for this opportunity.
Thank you so much, Rohan, and thank you so much, the esteemed speakers, for this very insightful information. We now leave the floor open for questions to our speakers. Sure. May I now request the Honorable Minister, Shri Murugesh Nirani, Minister of Large. Sorry. Sure, sir. If anybody has any questions, we can take it up, please. With your permission, sir, I'd like to just call you on, sir. Yes, sir. May I now please request Honorable Minister Shri Murugesh Nirani, Minister for Large and Medium Enterprises, Government of Karnataka, to address the attendees and the distinguished speakers.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good evening to everyone. I hope you all had a wonderful time listening to and engaging with the industry experts and the dignitaries present in the session today. Our Industries and Commerce Additional Chief Secretary Dr. Raman Reddy sir, our Industry and Commerce Commissioner Srimati Gunjan Krishna, Dr. Uma Maheshwaran, Isro, Bangalore, our young entrepreneur, Neha, our Pixel, just now I spoke, my good friend, youngest, I think this company, evening. Really, I hands up to you. It is very great, I have no any word to express what you did so far in the Isro and space, this work. I am positive that the mentioned by our ACS comprehensive overview of the developments in the aerospace and defense sector helped you gain an in-depth perspective on Karnataka's development and growth potential. Ladies and gentlemen, it is a fact that over the years, the focused approach towards the foundational developments of the aerospace and defense sector, as said by ACS, has led the holistic and potential growth in the industry. This has also led to the blooming of the well-connected support and ancillary ecosystem in the state. Karnataka, apart from being India's largest aerospace cluster, is also the second largest producer of heavy electrical machinery in India. Bangalore alone produces about 60% of machine tools in India. The state is also the second largest chip design hub in the country. Moreover, Karnataka has set up center excellence in partnership with Diesel system to provide industry-ready manpower. The state also has a strong base of around 2,000 SMEs that carry out subcontracting work in the aerospace and defense sector. Therefore, we well-developed support system for the sector has further facilitated the expansion of this industry while also attracting the global players to set up their base in Karnataka. I would like to thank Srimati Gunjan Krishna for giving us further insight through her aerospace and defense presentation. Her presentation was indeed engaging, informative, and executive, and I am hopeful that her suggestion, views, remarks will be well utilized by the prospective investors and other spokesholders present here today. I personally found the decision session very interesting. I am positive that the upcoming Indian startups will learn from the experience of the session's players and use their journey as the guiding path for their decision in the future. The speakers from the upcoming Indian startups infused a sense of vigor and fresh perspective in the forum. I am sure that the audience enjoyed getting familiarized about the developments these young entrepreneurs are making in the aerospace and defense sector. I hope that Mr. Satak, Mr. Godobin, Mr. Ahmad take home the learnings from the session and bring forth the same through their respective endeavors. I would also like to thank Sri Uma Maheswaran for moderating the session and helping in keeping the decision within the purview of the session. I am confident that the dialogues and exchange of ideas that started on the platform will continue and translate into the wonderful results for us to witness. I believe that this forum has rightly served as a catalyst to further nurture the fruitful relations, collaborate and grow together. And a big thank you to our engaging audience. I am thankful to you for the prospective interest and engagement displayed in the decisions. I would again like to express my heartfelt gratitude to the dignitaries, guest speakers, panelists, moderator, and everyone present here today. I hope the rest of your time in this magnificent event it has enjoyable as it has been for me today. Friends, really I am proud to say I am from Bangalore, I am from Karnataka. It is a globally, it is a IT sector, we are the number one in the country. But in space and defense, I think we are number one in the globe. It is because of you, whatever you did so far, your effort. I hope in future days, our Karnataka in the world map, will be the number one because of your help and your sacrifice. Whatever the help from our government and my department, definitely out of the way, I am ready to help you. You please take that advantage, any concession, anything. It is very difficult to speak. Whatever you spoke in this one, it is very difficult to tell the words. You please come and meet me in Bangalore, either our ACS sir, or commissioner, or in any, or KDB CEO. We are ready to with you and we will grow together. You please bring our Bangalore name in the globe. Thank you. Namaskara.
Thank you so much, sir. May I now please request the Honorable Minister to present a token of appreciation to our esteemed speakers. May I like to please call upon Mr. Uma Maheshwaran, Scientific Secretary, Isro. Thank you so much, Mr. Uma Maheshwaran. I'd like to now call upon Ms. Neha from Astro. Thank you so much, Ms. Neha. I'd like to now call upon Mr. Awais Ahmed from Pslv. Thank you so much, Awais. We'd like to now call upon Mr. Rohan Ganpathi from Bellatrix Aerospace. Thank you so much, Rohan, and thank you so much, Honorable Minister. Thank you so much, ladies and gentlemen, and that we'll be closing the seminar. Thank you so much for being here.